Hi everyone, and welcome to the Green Chemistry Connections webinar series. We're happy to have Andrew Dix today, David Laviska, Dr. Nick Kingsley here today to talk about a discussion around transforming green chemistry education. It's a follow-up to their models of transitioning to green chemistry education and higher education in April. That webinar is posted in the welcome chat box, so if you didn't join us back in April, you can check that out if you hear anything that you want to learn more about today. This webinar will be recorded and all attendees are in listen-only mode. If you do have a question, you can type it anytime into the question box. We do have people looking for the questions at any time during the webinar, so please make sure that you are asking them throughout. So we welcome you back to the Green Chemistry Connections series. I'm Dr. Natalie O'Neill. I am the Higher Education Program Manager at Beyond Benign, a nonprofit dedicated to green chemistry education in the K-12 and higher education space. This webinar series is dedicated to highlighting relevant topics in green chemistry education for faculty, students, and staff looking to adopt green chemistry in their courses and their programs. Today's webinar is co-hosted, and you see them here, lovely faculty members from our Green Chemistry Commitment Program, which I'll speak more about in a moment. Now for just some logistics as we move forward. As I mentioned, we are broadcasting live and recording this session. Therefore, all attendees are in listen-only mode and all lines are muted. If you do have a question, please type it into the question or chat box. And our moderator, Dr. Amy Cannon, our Executive Director at Beyond Benign, will be moderating that during the webinar today. We will respond to as many questions as we can. We hope that it'll be a very live and active discussion today. We will, in the end, have the option to unmute you if you do want to have a more conversational conversation with us today. The recording will be posted in the link you see in the welcome chat box and on this PowerPoint slide. Any of the documentations that are here today will be given as well in an email that comes to you as a follow-up to this webinar. This webinar is being brought to you today as part of the Green Chemistry Commitment Program, which is a consortium program aimed at transforming chemistry education, expanding the community of green chemistry practitioners, growing departmental resources for those looking to adopt green chemistry, improving connections to the industry, and effectively shifting how we teach chemistry today. This program is voluntary, it's flexible, and it's really about adopting green chemistry student learning objectives that are promoted and what you're currently doing at your institution and what you hope to strive towards changing your education to. You can find more information on the link provided, or you can email me directly. I'm always happy to talk to you about the Green Chemistry Commitment Program, and I know our signers are as well. So our speakers today are all Green Chemistry Commitment signers, and they'll be speaking about their unique departmental approaches to achieving the aims of their commitment at their institution. We do want to say that if you are or do participate in social media, please connect with us on Twitter and Facebook. We'd like to know where you're joining us from today, so you can either put that in the chat or shout it out on social media. We have our fabulous Juliana Vidal joining us all the way from Brazil. And we'd love to know where you are joining us from, so please let us know. Reach out to her on social media today, and thank you for joining us during this webinar and being a part of this community. So next, we are happy to have these wonderful speakers with us today. I just want to mention quickly that we do have GCC signers ranging from a different institutional level here. So we do have an R1, which would be the University of Toronto, an R2, which would be Seton Hall, and then a PUI, which is a primarily undergraduate institution with the University of Michigan Flint. We give you this background just to have an idea of if you're looking for work that might be relevant to the environment that's at your institution, to have this kind of background information coming into this. So I'm just going to quickly introduce our speakers, and then I'm going to turn it over to them. So we have Dr. Andrew Dix, is a professor from the University of Toronto. He is a green chemistry laboratory instruction guru, editing 3 books in the field and publishing many papers on the topic, and has facilitated his department in shifting to a systems thinking model. We have Dr. David Laviska, who is an assistant professor from Seton Hall. He is a green chemistry advocate and brought his department to the Green Chemistry Commitment in 2019. His passion in the department's environment has allowed them for many changes in a short period of time. We then have Dr. Nick Kingsley, an associate professor from the University of Michigan. in Flint, Michigan, is a green chemistry and systems thinking champion, bringing the United Nations Sustainable Development Goals across the chemistry curriculum to help global challenges. So with our introductions done, I'm going to let you take it away, Andy.
Thanks very much, Natalie, for the introduction. I think you're going to hear from David and Nick and myself today, really some different sort of perspectives on teaching green chemistry and sustainability. And what I think is an important message is there's no sort of one size fits all, and we have different approaches, but we're all working towards the common goal of trying to educate students about something that we think is very, very valuable and an essential part of their chemistry education. What's on the slide in front of you there is a bit of a timeline about what we've done at U of T over the last 15 years or so. We started teaching green chemistry back in around about 2005 by designing some new green chemistry lab experiments and integrating them into upper year labs. We developed a course based around those experiments in 2008 called Organic Synthesis Techniques, which is a course that around about 30 or 40 chemistry program students take each year. And although green chemistry isn't in the title of that course, it is a thread throughout the whole course, both within the classroom and the lab components of the course. We really then started with what we could control very easily, an upper year course with not many students in it, designed for chemists. But we really, in the early sort of 2010, 2011 or so, we wanted to really start teaching green chemistry to a broader population, and certainly think a bit more about teaching life science students. So in that respect, we certainly designed some new experiments for those cohorts, but we largely took experiments that we currently had in the course and tweaked them. And that's an important message, I think, from many educators who have started teaching these principles, is that you don't have to reinvent the wheel, and that taking a current curriculum and just viewing it through a green chemistry lens is certainly feasible, particularly for larger schools who perhaps don't have the budget to design lots of new experiments or the time to do that as well. So those are more sort of green chemistry reflections on experiments than designing brand new practical activities. A lot of this work has been done in conjunction with our Green Chemistry Initiative in the department. This is a group of around about 20 graduate students who are involved in promoting green chemistry principles, not just within chemistry at U of T, but beyond in North America. They have produced a very nice YouTube set of videos on the 12 principles, for example. We actually signed on to the Green Chemistry Commitment, and the GCI, the Green Chemistry Initiative, were key in this. We signed on 4 years ago, and that has provided impetus for us to spread the word more amongst the faculty within our department, and trying to incorporate green chemistry pieces into lots of different courses, which we think is one particularly useful approach to teaching. It's not certainly the only approach, but we find it's good for our circumstances. And Natalie mentioned that we are, if you like, a systems thinking department in that regard. We are trying to broaden out the teaching, not just starting with organic chemistry and general chemistry, but moving student exposure to these ideas within inorganic, analytical, and to some extent physical chemistry as well. So really trying to give undergraduates a perspective from the different subdisciplines in chemistry, what green chemistry means to those subdisciplines and how they can be incorporated and thought about in similar and in different ways. So if you're interested in that particular approach to teaching, we wrote an article last year for the Journal of Chemical Education in the special issue on teaching green chemistry from a systems thinking approach, and look forward to the discussion with you today about aspects of that.
Great, thanks so much, Andy. So with that, I'm going to turn it over now to David Laviska from Seton Hall. Oh, David, you're muted.
Sorry. Thank you for the introduction, Natalie, and welcome everyone. Thank you for joining us today. We're really happy to have you here, and I just want to give you a quick overview for those of you who attended with us on April 1st. You heard all three of us talk about some detail of what's going on in our departments, and we are quite different. And as Andy said, there are a variety of approaches, not only amongst the three of us, but more broadly. And I think actually that is something that people find daunting at times when they think about doing something new in their curriculum. Specifically, green chemistry is a lot of information. Where do you start? How do you get other people excited about it? Is it best to start small? Is it best to start with a sweeping change? And I think in general, it's not, as Andy said, a one-size-fits-all scenario, and just doing something really gets the ball rolling as long as there's enthusiasm and energy behind it. So let me talk a bit about Seton Hall. I'm very, very blessed to teach there. I'm just finishing my third year at Seton Hall now. And we came together, several of us, to discuss options basically in 2017. That's the first bullet point there. Seton Hall has been undergoing an extremely rapid expansion of science majors, particularly health sciences, but also chemistry and physics. And that had been going for some time, but a few recent events really increased that rate of expansion, most specifically the fact that Seton Hall opened up an affiliated med school, the Hackensack Meridian Medical School, back in 2017. So we have a big jump in enrollment, but also in New Jersey, where we're located. And I think this is important for everyone to think about your local community also and reflect on that, the needs of that community and in the context of where you are. We do have a lot of industry here. People do tend to be quite aware of their surroundings. We're fairly crowded. As we all see, unfortunately, right now with the COVID crisis, New Jersey is second only to New York in terms of the severity and numbers of cases. So keeping that in mind, we wanted to serve these students well and wanted to start thinking about some options. We were running out of lab space, too many lab sections. This is for the gateway courses primarily, general chemistry and organic. And we just wanted to basically start a conversation. So most change happens slowly, and I don't think any change happens in a vacuum. You need other people, and I am extremely blessed to have amazing colleagues, particularly Bob Augustine and Cedric Chanelian, who have for a long time run the Center for Applied Catalysis at Seton Hall, and then Cecilia Marzabati and Rory Murphy, who are senior faculty who are extremely excellent and interested teachers. And so we came together as a group and started discussing this. That's, you can see the third bullet point, in 2018. So because we had a lot of energy and because they had welcomed me so enthusiastically into the faculty, I gave a lot of ideas. I had been thinking about green chemistry for a long time, primarily because I had worked in other institutions where they did not have good facilities, running organic labs without hoods, for example, these sorts of things, which really made me think. And I also participated in a green chemistry workshop about almost 4 years ago now, with Professor Andy Dix, actually, as one of the content experts at that workshop. But that had lodged in my brain, and as my colleague Rory said at one point, this is really a win-win-win-win-win. There's no losing to any of this. There's no downside. All of these things are good things to think about. And it turns out that the tenets of green chemistry, ideas like systems thinking, sustainability, stewardship, these align extremely well with the mission of Seton Hall overall. So we were able to, in a matter of just that summer of 2018, put together a plan, and we got immediate full faculty support in the chemistry department at the first faculty meeting that September. So we could say we had full department buy-in. not that everyone is actively involved, but everyone is supporting the initiative. And I would like to add that the administration has been extremely supportive and interested as well. And I think that's primarily because they see how good it is for students, and it does align well with our university mission. So we've done a lot of things, and I'll be happy to talk about that as we go, but I really just wanted to let you know that everything is daunting until you get started. So start somewhere and talk to people, talk to us, reach out to us, talk to Beyond Benign. These are incredible people. I feel such a sense of privilege being welcomed into this community, and they've done enormous amounts of work, and it's really on their shoulders that we are standing at Seton Hall. And hopefully someday our shoulders can be ones that other universities stand on as well. But this is a building process, and the number one message really is that it's a win-win-win-win. There's no downside, and students are incredibly interested. So I'll leave it at that for now. But by all means, please make this a lively discussion. Join in. Every question is interesting to us. So hope to talk to you more shortly.
Awesome, David. Thank you. So with that, I will turn it over to Nick Kingsley from Michigan Flint.
Thank you, Natalie. So I'll keep this brief so we can get to time for questions from everybody. We signed the Green Chemistry Commitment in 2017, but our journey in green chemistry kind of starts all the way back in 2010 when I was hired in, and we had a U of M Flint, and we had another faculty member, Dr. Jessica Tischler, who had done green chemistry research in graduate school and had interests, and it was kind of nice to have two people together who had the same passion to kind of get things moving. And I think we, for the longest time, are in the same boat that a lot of people are in, is how do we get started? Where do we go? What do we want to do? And I think the message I want to deliver is that it's so important, as David just said, once you get started, that the getting started is the threshold to get over, because once you do, the momentum builds and the drive builds, and people get excited. And so we've done green demos with our chemistry club at high schools and elementary schools around the area. We do some green chemistry focused research. Is a part of our Bachelor of Science degree in green chemistry. Students have to take a sophomore level research class, a sophomore level research course that we work with them on, taking some of the labs that we have around our department and trying to find ways to possibly green them. And then they spend their time doing research and working out the methodologies of those. We've worked on creating and implementing not just green chemistry principles, but also systems thinking, United Nations Sustainable Development Goals, environmental justice, social inequality, drop-ins throughout general chemistry, organic chemistry, and our upper division courses where relevant to give the students some context to why the science they're learning is important and relevant to their everyday lives and to the future of our society. And it's really nice to see on the back end in things like student evaluations where students unprovoked give direct commentary about the joy they get from learning about those things and how it's inspired passion within them to change the way that they're doing things. And it's just a really good opportunity to give context to those students. So in 2018, we started our Bachelor of Science degree in green chemistry. We have 4 graduates of the program now, and we have more that are in the program starting as freshmen. And it's nice because as we continue to grow, we can tell the stories of what those students are doing, the things that they're going on and doing and how they're making an impact. And the one thing that I kind of want to drive home in terms of how do we get initiatives going, I mean, any step is a first step. And I would argue that I think, especially from a green chemistry principles, systems thinking approach, there's a lot of things that people out there are doing in their classrooms every day that maybe they don't make the connection as actually teaching green chemistry principles and systems thinking approach. And people probably have already taken first steps and just don't even realize it. And it is amazing, especially at our institution, how many colleagues outside of the sciences and the social sciences, the humanities, the arts, have shared interests with us in some of the things that we're trying to teach students in these courses, on top of just the core science about why what they're doing is important. And so with that, I will kind of stop there and then give time for people to ask questions to us.
Awesome. Great, Nick. So we do want to learn a little bit about you that we have on the line today. We do have 57 people joining us. And so I'm going to ask Amy Cannon if you could launch that poll for us to see who we've got on the line. Great, so there are multiple options here. We want to know a little bit about your background. And you can pick multiple things here so you don't have to fall into one box. Are you new to green chemistry? Have you been in the community for a while? We'd love to know. So it does look like we have some people new to green chemistry, so you're in the right place, you're with the right people. I'm sure they're going to give you some starting points today. As you've heard, the biggest barrier is just getting started. So again, you're in the right place with the right people. And so it looks like we'll give you a few more seconds, but I would say we could close the poll to see who we've got with us today in the audience. Great, so we can share the results of that poll out.
Yep.
So it looks like the largest majority that we have on the line today is higher education faculty and staff, but we also do have a lot of graduate students and undergraduate students on the line as well. So I look forward to hearing the questions that come in and also kind of tailoring it to the audience that we have here today. So Amy, do you want to start with the questions that have come in?
Yeah, great. Thank you all for the first webinar that you did back at the beginning of April, and now for starting this discussion. We did want to try to make this a little bit more interactive, so we do have the ability to unmute you. So if you feel like you'd rather, instead of typing in a question, you'd rather use your voice and ask a question, then please raise your hand. So you should be able to see the raise your hand function in your chat box and or in your control panel there, and we will unmute you for you to be able to ask these lovely folks your own questions. So, but to get us started, I was going to start with some that came in from the registration. So there was a couple, so maybe some of you who are attending might recognize these as your own. And I thought one of the ones is a little bit more broad in general, and it talks about basically in general how to incorporate green labs in place of traditional labs. And since oftentimes labs are a place where green chemistry implementation starts in higher ed, I figured maybe we'll start there. If you could share some of your own experiences. I know you guys have a wide variety of experiences in this space. So maybe share a little bit about that either tips or tricks or challenges of incorporating greener labs in in replacements of traditional labs.
I'll start if you like. Yeah, it's a really good question, and it's something that I think a lot of people puzzle over. For me, it's not. We're all doing some green chemistry already. We're just not necessarily all calling it green chemistry, and that's the point I think Nick made earlier, and it's a really, really valuable point. So what I think we can do for any lab, really for any course, maybe starting with Gen Chem and organic courses at introductory levels, is look at what we're currently doing and thinking, can I look at this current experiment through a green chemistry lens? That is to say, what is green about what I'm doing in this organic synthesis or this Gen Chem experiment? Am I using a particularly green solvents or whatever? What's not green about what I'm doing, and how can things be made greener? And if students are asked to reflect on experiments in that way, and that was really an approach that was put forward by Tom Goodwin quite a long time ago from Hendrix College, and something that I read and really was a whole game changer for me. I read that and I thought, wow, we could just do that. We don't actually really need to change anything practically in our labs. We'd already developed some new labs at that point, though. That is something that we can all easily do. There are a lot of now resources available from Beyond Benign, published in JChem Ed and other places, which could be taken as well, and are just like nice drop-in labs too. If somebody wanted to take something that has already been developed, or simply get a nice approach at maybe a upper level courses and so on, is to get students to change reaction conditions, for example, from a traditional method. Say to students, what might you change here? How might you make this process greener? Let's run this reaction in a different solvent, which is greener, and let's see what happens. And that gives students a little bit of participation in their chemistry rather than following recipes. And we've had a little bit of success with that approach as well. So, there are lots of different strategies, I think, that can be done in a lab perspective.
I'll jump in here. I think there's a lot of things we can do, and things that maybe people wouldn't necessarily at face value view as green chemistry in terms of the chemistry of what you're doing. But even in like an undergraduate Gen Chem lab, where typically we'll have students make series of dilutions of compounds to run UV vis on and collect and make Beer's law plots. We used to do that experiment just using Kool-Aid or red dye, and so you can tell the students why we're going through the same technical skills of making solutions, doing dilutions, but there's even other things that you can expand upon. So fine, we've switched to using Kool-Aid, which students may think is non-toxic, but even in Gen Chem, it gives an opportunity to talk about the toxicity of a lot of the dyes that we use in a variety of different things. And so even though we're making a replacement of something that seems benign and an easy replacement for some of the chemicals we were using before, it still gives an opportunity to talk about toxicity and things that are important to them related to what we're doing. And so, also, if people are teaching general chemistry, we implemented a lot of sustainable polymer labs across our general chemistry curriculum, first and second semester this year in the labs. And the students had profoundly positive things to say about what they were doing in terms of, working through those experiments and learning about the green chemistry principles related to them. And there's a lot of great work out there coming out of the University of Minnesota related to those, and a lot of it's published in JChemEd, and there's some really great things there that are easy to implement, that aren't cost prohibitive to do. That is a great first step for people out there.
Yeah, and I guess I'm going to add too, just very quickly, which is to follow on what Andy and Nick said. There's one more piece of this, which I think is the actual implementation piece, whether it's having students think about the experiment, or changing the experiment slightly, or changing the experiment completely. It involves adjustment, and most of us who teach, which is probably all of us, because it doesn't really matter on the size of your institution or the class, you kind of want to know what's going to happen before you do it, right? That's one of the problems with changing, is that you don't want to get in the midst of something in a curriculum and have it go sideways, or the students really not learn something, or there's always, if possible, you want a vetting process, I guess is what I'm saying. And one way that we've been extremely fortunate is, and I think this could apply to a lot of schools, undergraduates really want research experiences. They tend to learn a limited amount in their coursework labs because there's simply not enough time, and there's a lot of corners that get cut generally, not so much by faculty, but the students themselves. And giving students the opportunity. So we replaced our entire organic lab sequence, replaced or refined our entire organic lab sequence overnight, from one year to the next, basically, which took an enormous amount of work, but would not have been possible without my undergraduate research students running through and piloting all of the labs ahead of time to see what works and what doesn't work, and what we can anticipate with students who are really not, focused in the same way in a big course of a lot of students. So I think making these things part of a research project is an extremely valuable thing to do as a route toward implementation. And it takes a lot of the fear out of the actual ultimate implementation. It takes a lot of the fear out for the faculty who are trying to do it.
Can I follow up to David there real quick on that? One thing I just will share that I just had a conversation with a colleague yesterday about was the fear of failure when we go to implement these things maybe isn't as big of a fear as it should be. We, on our campus, we don't always have time to vet all these things before we do them. And it's really interesting to see the excitement in the students' eyes when they see the vulnerability of us coming into lab to run something that we haven't vetted. and tell them that, listen, we're trying to research what the best way to do this is. And then they kind of feel a little special, like you're trusting us to work with you, to work through this. And so sometimes, even if we don't have the full answers and the lab goes terribly wrong, students still get joy out of that because they feel like they're a part of something bigger than just taking this lab course to be taught something. They're a part of the bigger picture of what we're trying to do as a department and institution.
There's no such thing as a failed experiment, is there? Sometimes that's what we say to researchers.
Yeah, we learn that early usually. That's great. We've gotten a few, I'd say 3 or 4 different questions on systems thinking, and I think each of you might have brought this up in a different way. So we had one from the previous webinar that we didn't get to answer, thinking about systems thinking, and if that's an opportunity for more interdisciplinary collaboration between departments on your campus. And then we've gotten a couple others from, can you expand, what exactly is systems thinking? And then expand on, and it sounds like people also want to hear how you're integrating systems thinking into your courses and programs. So there's kind of a lot in there, but maybe each, you each might have your own unique perspective on this. So I don't know who wants to start.
Well,
Yeah,
let me start because I don't have a lot to say here because we're so new, right? Because Nick and Andy have done a lot of work in this area, so I'll defer to them. I can just say that at Seton Hall, we're aware of the value of systems thinking, and I like to think of it as giving the students a broader context for what they're learning. And we've done some things, but it's all extremely preliminary. We envision as a green chemistry committee absolutely broadening to other departments. I know Nick is probably going to talk about the interdisciplinary part of this, but we're just so new in this initiative that we're just getting going. So we're really in the brainstorming part of this, and I've done some things, but I don't think that, I think Nick and Andy have much more substantive things to say. But my point would just be contextualization is already, it's clear to me it's a very powerful thing for student learning, and I'll let them take it away.
go on, Nick.
So I think that I'll say that I think that people who are curious about how to incorporate systems thinking into their classroom are probably already doing it. The way we use systems thinking in our courses a lot of times is when we talk about different topics, we really try to get the students to think more broadly about the impact of whatever it is they're doing. And we kind of take it from a boundaries approach of students a lot of times view, especially in the labs, in the laboratory curriculum, that where did this chemical come from? Well, it came from the stockroom behind that door, or this solvent, so we try to give them an opportunity to think about where some of this stuff is sourced. In my upper division inorganic lab, which is the last lab any student takes in our department, we do a project at the end of the semester where students have to pick an experiment they've done on campus, and it could be at any point across their curriculum at U of M Flint in the chemistry department, and try to source back as far as they can where the chemicals they were using in that reaction came from. And students get a real profound sense of, wow, this chemical that's on the shelf, and even if it's a chemical that maybe doesn't have any hazards associated with it, that doesn't mean that in the development of it, the sourcing of it, that there weren't things being done. And when we talk about energy in the class, talking about energy solutions, where we live in Michigan, where Flint is situated, there's a lot of wind farms just north of our campus. And so we talk about what kind of materials go into building those wind turbines. And where students think that, oh, well, I have a wind farm near my house, so my power source that I'm getting energy from is a green alternative to just running from a coal burning power plant or something. But when we start talking about where some of those rare earth metals are being sourced from for making the magnets and things, it just gives them a broader scope of how what they're doing and what they're exposed to is actually being impacted. Talking about solar panels and the lifespans of them, talking about the chemicals that go into producing some of those solar panels, where the solar panels end up at the end of their use. They're not currently easily recycled, things of that nature that help give the students, and the big one for us in our campus is talking about lead and how lead ends up in the water is a big one. And it opens up a lot of opportunities talking about how do we do disinfectant treatment, how do we oxidize out the organics, and it all relates to solubility product, which is a large chunk of general chemistry too on our campus. And so it really gives students some broader perspectives on things that helps them tie in that core chemistry concept, solubility product, with something in their everyday lives that they're exposed to.
I think Nick's given you some great examples there within courses and so on, and certainly some of the things he mentioned we do at U of T as well. We do a fair bit with our Centre of the Environment, and there are connections. We have an environmental chemistry specialist program and an environmental chemistry minor program, and systems thinking is particularly built into, I think, nicely into those programs. The JChem Ed paper that we wrote that has been highlighted on the screen there, and it was on the slide earlier, was really talking about our department as a system, if you like, in terms of teaching green chemistry to undergrads. So we have, as I mentioned, adopted the approach to try and embed green chemistry into sort of 6 or 7 different courses, and those are in the different subdisciplines, and the instructors talk to one another about what we're doing. And as David has mentioned, quite a number of the activities that we've developed for labs and for the classroom have been put together by undergraduates, and we have our graduate green chemistry initiative that contribute as well. So there are sort of inputs into the departmental system, if you like, in terms of developing resources. There are outputs from our departmental system in terms of our green chemistry initiative, developing YouTube videos, advocating within the department for things like shut the sash campaigns, energy reduction campaigns. We purchased a solvent recycler a few years ago to recycle acetone from research labs. We're developing one for teaching labs at the moment. So it sort of inputs into a system, outputs from the system, but thinking about a very sort of integrated approach within our department regarding teaching green chemistry and sustainability, and not adopting the approach where we have a green chemistry course. And that is an approach that certainly is adopted and is a great approach in many respects at other places. We try not to give the impression to students that we have this separate new subdiscipline of chemistry here, and this is where you learn your green chemistry, and it doesn't impact other areas of the discipline. So we've adopted just a different style of teaching.
If I could follow up on that real quick, one thing that I think is really nice about the systems thinking approach in chemistry education is, especially for the students who aren't science majors, the pre-professionals, when we start talking about life cycle analysis in class and other things related to systems thinking, it takes away that reductionist approach that they view out of our class, where there's always a defined right answer and it's either right or wrong based off of what we're doing. And we start thinking about things a little bit more holistically, and they really enjoy that part of the class because they like the fact that maybe there isn't one final correct answer, and there's a lot of different things that we can think about, and that every time we make a different decision, it's going to change the output of what kind of thing we're looking at.
So let me throw out one last thought here that occurred to me, because I know that people are looking for advice, at least some of them. One very, very brief example of systems thinking, or one thing that you can use yourself in any class that you teach in chemistry, I think it works particularly well in general chemistry, is at the very beginning when you're just learning about elements and so forth, ask your students, survey your class, ask them where helium comes from. Right, that's a life cycle analysis in a nutshell, basically, right? Where does it come from? What happens to it? Can talk about once it's released, it's gone, right? And where does it come from? I'm not going to give away the answer to people who don't know, because there's probably some people in the webinar who don't know. Hopefully not, but maybe. And students don't know, right? And that's not weird. That's not surprising. It's not something that we walk around with in our, it's not something people talk about. And so when you talk about things like that, and give students context for what helium is used for, aside from balloons, and why the price has skyrocketed and so forth in recent years, and talk about limitations. It takes a discussion of, it takes a broader context out of what they've heard 1,000 times, which is limited fossil fuels for cars and trucks, right? And brings a slightly different tint to it. That's system thinking. That's giving a broader context. It's one small bit, but that's a very easy place, one specific example that anybody can start with.
I love all these ideas, and you guys touched upon something that I'm hoping we can get to, which is the non-chemistry major course. But I'm going to get another voice in here. So we do have a hand raise here from Tisha Jessup. So I am going to see if our technology works here, and I'm going to unmute you for your question.
Aha.
There you are.
I appear unmuted. Okay, everyone can hear me?
Yes.
Great, thanks. My name is Tisha Mendiola Jessup, and I am from the University of Colorado, Colorado Springs. And my colleague, Nikki Jewell, is also on this call. So I'll be speaking our question. We currently teach a Introduction to Chemistry course that has quite a few health science majors in it, with the intention of going into nursing. And a handful of them end up in a Gen Chem track. But most of them are in a nursing track. A number of them are sort of undeclared universal studies. We've had the handful of English majors and engineering folks in. So as a part of our sustainability flag for our university, we decided to fulfill the requirements of sustainability through the lens of green chemistry. And we thought it was an easy adaptation to just include green chem. And we used the Beyond Benign course last summer, which was fantastic. And we have read, I think I have read a paper, I think I've read Andy Dick's like 15 books and all of your papers, and incorporated a lot of these things that we're talking about and things that you've linked to. And we've got, I think we concur that a lot of the student feedback has been incredibly positive. We've gotten a lot of, why didn't anyone tell me this? Why am I just hearing about this now? And we adopted it in our second semester, which is the Intro to Organic and Biochemistry. As we've kind of seen, it lends itself very well. Green chemistry lends itself very well to OChem and Biochem. But they asked us, well, why didn't we learn this in Intro Chem's first semester? Why didn't I learn this in high school? Why is this new to me? Which we've attempted to answer. But what I would like to ask you, especially you've been doing it for a while, or David, maybe you're just starting to get the first round of feedback, we've also gotten some pretty significant pushback from the students. Some of it has been mean, accusing us of having a political agenda for being the environmental, the radicals and changing their minds. And we're like, yes, we are changing your minds, but not in the way that you're essentially accusing us. And one of the things that this semester, this will be the second semester we've done it, is at the end of this semester, I propose that we ask them why this is important. And some of them, I think, still did not grasp why learning about green chemistry and healthcare is important. But also some of those folks who were adamantly against the incorporation of sustainability and green chemistry principles, why they had to learn that in their chemistry lab when they wanted to be nurses. I think that was the actual direct question to us. Can you give some thoughts and feedback, or maybe some advice on how we can preemptively, I think David just brought that up, like, how do you vet that? How do you anticipate, as teachers, how do we anticipate some of those questions that we're going to get? And how do we, how can we be best prepared to answer those kinds of pushbacks?
Yeah, that's a really great, if I can start, that's a really interesting observation about the students pushing back, first of all, because I've seen a tiny little bit of that at our school on the old student evaluation. Why are we learning about this? What's the point? This isn't real chemistry, or something like that, something along those lines, but very, very rare. I think one thing that we've done, and this was mentioned earlier, and I know that Nick and Dave, I think, will echo what I'm going to say, is we frame quite a lot of our discussions now around the United Nations Sustainable Development Goals, which are a great framework, I think, for students to look at and for us to explain to them as educators and say, okay, we've got all these goals. What role does a chemist play, or can a chemist play, in trying to attain these goals? And you can go through essentially all of them and say the chemist can do this, 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 and this. And then with that framework in place, sort of drill down a little bit in a particular course and say, right, okay, which of these goals do you think this course might be linked to, for example, clean water or whatever. How might a chemist be involved, or what principles you're going to learn about will be involved to help in this regard. I think that those UN SDGs have been really, really influential in green chemistry education, and they get mentioned a lot in publications now, pedagogical publications, and people hold them up as so. I think sometimes perhaps you mentioned that students think you might have an agenda, and it's a personal agenda or it's a departmental agenda. No, it's actually a world agenda. And if you want the big picture context, the UN SDGs are right there.
One thing I'll add to that, especially for the people who feel that maybe you're trying to have a politicized agenda or something, if students in my class give pushback on those types of things, I try to relate back to them. The science is the science. Increased CO2 emissions is a problem. We can leave out the discussion of what is the best policy to reduce CO2 emissions, but if we don't reduce CO2 emissions, we're going to hit a critical mass, if we haven't already hit the critical mass of CO2 in the atmosphere. And we can have that conversation because CO2 being an issue is separate from political, at the science level, is separate from political debate. And so we can kind of try to skirt that a little bit, but the UN Sustainable Development Goals is, I think, a big piece. Also, I think, though, that even from people who are pre-professionals, right, there's opportunities to have discussions about things that are related to their lives that might be of interest to them, talking about drug delivery technologies and the fact that a lot of these drugs, after we consume them, end up persisting in the environment, and issues related to that type of process can be beneficial to them, maybe along the lines of being pre-professional and what they want to do, to say, hey, here's something directly related, right? You're going to be prescribing medication to people, and here's some of the long-term ramifications for some of those medications, and how can we design better medicines that have more targeted approach to their activity and things. And so there's different opportunities there, maybe to touch more directly related to what they're interested in along those lines.
Yeah, and I mean, I love what Andy and Nick said. I don't, need to really add to that part of it. I think you can, not being in your classroom, right, it's hard to comment on how you're presenting any of this. And it wouldn't really be my place to do that anyway. So it's hard to get the student perspective. But what I can tell you from experience, since I also teach myself, I do not teach the majors. I teach the non-majors, which are at Seton Hall almost entirely life sciences majors of one kind or another. Knowing your audience is always important, and you're probably not doing anything wrong, right? In other words, you're probably not really making any mistakes here. There are always going to be students who push back, always. And if you take a student population Life science majors aren't typically that jazzed about chemistry to begin with. There's a reputation that comes along with it. They may, and I'm not really speaking about my students in particular right now, I don't want it to come off sounding that way, I'll just be very general, but I have taught in a number of institutions, and my observation has been that there's a larger proportion of them that just kind of want to do the basic thing and get it over with. They just want to tick off the box, get the requirement out of the way. And so by overlaying, which I think you're quite right to do, and one of the things we're looking at is expanding this to our pre-nursing courses also. One of the things that is always going to be the case is when you ask students to think, there's always going to be pushback, right? And one of the things about this green chemistry approach is asking them to think about things, asking them to evaluate, asking them to make comparisons. So I'm not surprised. I get some pushback also, not a lot of pushback, but there's always some, and it's because there's always going to be a certain baseline of students who just really don't want to do anything extra. They just want to do the stuff that's the most basic, straightforward stuff and not really have to think. And I think the proportion of students that fall into that basket are probably larger in a life sciences based chemistry class than like a chem majors class, for example, where they have a certain inherent amount of interest. So my advice would be to just not be discouraged by it. I know it's hard to read. I don't like it either when I get things like that. And this is the time of year, here they come. But you know, it's something that you probably are not doing wrong, but I suggest, as Nick and Andy said, use the United Nations Sustainable Development Goals. If you don't already know about them, then look them up online. They're very easy to find, and it's really quite amazing, the breadth of it and the world context that you can use to format your discussions, and maybe that will help them.
If I can just add one quick thing on, Nick said something earlier that was really important, and students, you know, liking the fact sometimes there's no right answer. Sometimes as well that makes them really uncomfortable, and you know that it's gray chemistry. Sometimes, you know, I think of it as gray chemistry because there isn't a right or a wrong answer. There's just an educated answer based on the evidence in front of us, and that does create discomfort amongst students, and being comfortable with being uncomfortable, as we all are at the moment in the world, is a really important skill to master. But it does create the pushback, I think, that we see from time to time.
That's wonderful. And we've had some good comments coming in here, so we're trying to address and send them out too. I love this discussion. So building on this, we had some questions come in about the chemistry courses that are taught to non-chemistry majors. So I wonder, you know, if you could talk a little bit more about that. There was some specific questions to biology, and not just for the lab courses, but also lecture courses for, you know, making the case. And I think you guys already brought up some of these things in this discussion already. But just, you know, any more tips for those, you know, the other disciplines that chemistry department supports in their teaching?
I'll go first. I think the chemistry courses for the non-science majors is a really great opportunity to incorporate some of these things, because, you know, in certain regards you have more time to devote to that. I mean, we don't spend as much time on the hardcore science in those classes as we do as a majors course or general chemistry, organic, and there's a lot of tie-in. And I think that I would say that any of the topics that maybe we view in a general chemistry, organic chemistry course where we could implement green chemistry or systems thinking, United Nations Sustainable Development Goals, we could do the same thing in our intro courses for the non-science majors. I'm teaching currently our pre-nursing chemistry course this spring, and my intention was to incorporate a lot of that into the class. But now that I've had to convert it from face-to-face to online, some of that's going to get lost in the transition, which is a little sad for me, but we still are trying to do a little bit of it here and there as drop-ins when you can. And I think there's a lot of opportunity there along those same lines to incorporate those topics where relevant, especially when we don't have to spend as much time on the hardcore science that we do in the other courses.
Wanna go,
Amy,
Dave?
could you clarify, Amy, did you say non-majors or non-science?
Unmuting myself. One question was very specific to biology. So that is chemistry, general chemistry, inorganic chemistry taught for biology majors. And we've had a couple others just for other, again, supporting other departments that are science majors, but not chemistry.
Yeah, so our completely brand new organic, our overhauled organic lab sequence is for our non-majors, actually. That's where we started because it's a much bigger class, and of those non-majors, 97% of them are taking our biology majors of one kind or another. So that's almost the easier place to start because increased safety, increased focus on connection to biology and the environment and a host of other things is reasonably relevant for those students. And again, so I teach the general chemistry to biology majors, non-majors, and like the helium example, I just discuss things like that all semester long for both semesters and give them context. And I also run the lab course, and the overhaul of that is currently in process. So right now we're not asking them to think about a lot of green chemistry stuff, but I did start with scaffolding based on the United Nations SDGs this year. So we are going in that direction, but I think it's equally relevant, right? It goes all the way back to what I said at the beginning of it's a win-win-win-win-win. There's really no bad here. And the only bad is probably what the commentator asked in her question from Colorado. I'm sorry, I've already forgotten your name, but that was a really good question. And I think Andy's parting comment was the best one, right? Which is sitting with the discomfort of not having a clear answer. A lot of students, especially non-majors, just want a clear answer so they can kind of get through. But I think the relevance is unquestioned, and we just plow ahead with it and don't really worry about the negative feedback. And to be honest with you, the positive feedback is far, far overwhelmed the negative. I mean, by far. Students love thinking about these things, and we also get a lot of why haven't I heard this before? You know, how am I just thinking about this now? So
Right.
I don't really have a great amount to say about linking with other departments rather than beyond, talking about UN SDGs. But one thing we tried to do a bit with Gen Chem, we face a really big challenge with teaching Gen Chem at our school in terms of the heterogeneous nature of the class. We have about 1,800 people taking first year Gen Chem at U of T, and maybe 10% of them go on in chemistry, and most of them go on into another life science or a life science area of some kind. One challenge we face is that students think it's just high school chemistry again, particularly in the first few weeks. So in the sort of introductory material where we talk about reaction yields and so on, that they've seen that before and potentially switch off, we bring green chemistry in there very early, and we say, well, reaction yield is one way to think about the efficiency of a chemical process, but here are these other metrics. And what are the pros and cons of atom economy as a metric? And what does that look like? How can we set that up? And I think students, obviously that can be linked to the 12 principles very nicely and be introduced very early to students. And that's quite an eye-opener for them, and they can see that from a class perspective. And we actually have students do a very early experiment where they measure atom economy for a very simple reaction of just magnesium metal and hydrochloric acid to make hydrogen gas. They work out the atom economy for that process, and I think that causes people to think in a different way. That's a little bit of an eye-opener. So that's not really a link to other departments particularly, but just a way that we try and engage largely life science students with some green chemistry principles very early on.
Great. I know we're coming up against the hour here, Natalie. I don't know if we wanted to try to squeeze in one or two, or how you're feeling with that.
It looks like we do have people staying on the line, so I think we could have time for one more question and then wrap it up. But there are so many great questions coming in, so we'll have to figure out how to keep this going and keep this discussion moving forward.
I know. I see some really great questions, and some are very specific too. So, and then I see. Okay, so I guess I saw a few that have come in to talk about advanced level courses. So like Andy, I know you had a great publication on an advanced synthetic course, so maybe we could post that reference, or if you wanted to mention that you have at U of T. But and so advanced courses, but also the upper level inorganic and some of the other subdisciplines beyond general and organic. So maybe we could, address those, and I've seen a few of those questions.
I'll start. We do currently in our upper division inorganic, really the main thing we've done is the sourcing experiment, where they look at an experiment they've done and try to trace back where the reagents are using, and they give a 5-minute presentation at the end of lab. We are in the process of looking, or I guess I should say I'm in the process of looking at ways to green up the experiments we do in our upper division inorganic lab, and that process was supposed to be taking place this summer, but with our labs and campus being closed, I'm not sure if it'll be ready for trial in winter or not, but thinking about ways to do that. In lecture, it's the same content. When we talk about relevant topics that we can tie into, whether it's the sustainable development goals, whether it's any of the green chemistry principles, and we certainly do that in lab. Even if we have an experiment that certainly isn't green by any measure, we do talk about the 12 principles of green chemistry and ways that we could think about making this experiment better in terms of what they need to include in their report, so that at least even if the experiment itself isn't green in nature, the students are thinking about what it is we're using in those experiments that we should think about trying to find replacements for down the road.
Yeah, as Amy mentioned, we've got a couple of upper year courses where very kind of intensive analysis and life cycle analysis and so on that we do with students. I think I mentioned at the beginning today that sometimes starting with an upper year course, because it's smaller course typically, and as an instructor you may be the only person teaching or teaching with one other person, that can be a great way to start something. The barrier to starting, as we talked earlier, is often the big one. But if you can control something and it's not going out to lots and lots and lots of students, that's maybe a good way to start. In one of those courses, we do sort of teach green chemistry as a thread all the way through, and the sort of capstone experience in the course at the end is where students design their own synthesis of a particular a molecule. They have a couple of weeks. They plan a method to design the synthesis of a target compound, and we say to them, okay, show us what you can do in terms of making it as green as possible. So think about all the things we've been talking about, show us what you can do over sort of 9 hours, two lab periods, and they have to do sort of a 3 or 4 step synthesis. And coming up with that sort of experimental design was not actually as difficult as it sounds. It was just thinking about, okay, as with most experiments, what do we want the learning objectives to be? What sort of budget have we got? Students are picking chemicals. They have to do their safety, very, very thorough safety analysis and stuff like that. They have to think about the relative toxicity of the substances they want to handle and safety concerns and so on. And that is part of the decision-making process that we've been talking about earlier, and the very much, okay, well, I've got to make this decision. Do I use this solvent? How long am I going to do the reaction for these reactions? Am I going to heat them? Am I going to use a microwave oven? All things they've seen before and thought about in the course. So it's quite a nice, I think it's quite a nice capstone experience for them. Took some time to develop, but as I say, it wasn't as difficult as maybe it sounds.
Well, I don't have a lot to add here because we're so new that we haven't gotten to the upper level courses yet, but I can give you one slightly different way of thinking about this. I don't know exactly who's asking the question and how many people are interested, but I said in the beginning about the vetting process, and I have undergraduate research students. At the moment, all of my research students are undergraduates, and I started them as partly vetting and partly learning for them running these green protocols. And I did not before then, but I do now and will always have now, a part of my research initiative being pedagogical lab development, because it has been such a fruitful area of exploration for my students. That is not all we do, but those students, all of them who piloted those labs, have moved on to my scholarly interest in research now. I'm an organometallic chemist, and I won't go into all of that, but they are doing remarkably good syntheses, organic syntheses, building ligands and making metal complexes, and they're doing it all through a green lens on their own because they have been trained to think about those things already. So we have already in hand a number of new molecules that have not been made before, and new or improved syntheses that utilize the tenets of green chemistry, simply because my students have thought about it from that angle. And several of these things are already being written up to be incorporated into higher level advanced coursework, because they can be done in a similar fashion or with a different type of molecule with an eye toward teaching or that kind of thing. So that's one way to think about development of this kind of teaching material, is through that sort of pipeline. And maybe that's unique to us because that's just the way it evolved, but I think it's worth thinking about the training of students in that respect. And I think it can work equally well for graduate students.
Great. So I think we are running up on time here. I will just say that we do have a recent grant with Millipore Sigma to work on a resource guide for the inorganic level, so that upper level that is asked about. And that's something that we're going to be kicking off over this summer. So if you are in the inorganic space, general chemistry space, and want to come work with us on that project and have some input on that, we would love to have you join us. So we're just going to finish up here. We're going to say thank you so much to Andy, Nick, and David for your wonderful presentations and the discussion you've hosted here today. It's absolutely wonderful. I know that you've given people a place to start from. And thank you for telling us how you're implementing the green chemistry commitment on your campus. So thank you all for joining us today. We do just want to give you a few more things in terms of what we will be doing next. So we know that everybody is kind of adjusting to a fluid situation. So we do have resources, virtual green chemistry learning resources posted on our website. If you're working towards things or you find resources that you have been using in your courses, please share them with us. We'd love to share them out with the community as well. If you enjoyed what you heard today and being in this discussion with us and would like more events like this, please let us know. You can submit your ideas for webinar topics through our Google form, and we will reach out to you in setting a time and date for that. We do have coming up next through this Green Chemistry Connections webinar series on June 3rd, a sneak peek of the education symposium that will be at the Green Chemistry and Engineering Conference that is in June. The Green Chemistry and Engineering Conference is hosted online this year. It's completely free. We urge you to register and come interact with this community, this lovely community that will be there online. It's a great way to network with leaders in the field, and we hope that you'll see us. We'll be there, so we hope to see you there as well. We're also thrilled to announce that we're going to be hosting our 3rd annual Green Chemistry Commitment Summit on June 25th from 12 to 3 p.m. Join us with the GCC signers to network with like-minded colleagues, a lot like has happened today, to participate in interactive sessions, share best practices, and brainstorm ideas to advance green chemistry in higher education. So with that, we'll say thank you for joining us today. We do have one more final poll just to hear what you would like to hear from us next. So what's next that we can bring to you? We will have that open as people are joining or signing off with us today. So I will share that now. think we're experiencing some technical difficulty on that poll. So I apologize there. So we will just say thank you for joining us so much, and we will hear from you in the future.
Thank you.
Stay well.